Hey guys, today we're going to be talking about neutralization reactions in chemistry with acids and bases. How many guys have ever gone to breakfast with a family and uh, before you left, you brush your teeth really good and you ordered a glass of orange juice and you've had that just nasty taste in your mouth? Well, this is a neutralization reaction that takes place in our mouth. And so when an acid and a base react together, the acid in this example would be the citric acid from the orange juice. It reacts with the base that is coated your mouth from the toothpaste, which has cleaning reagents in it that are base molecules. And when those two things react together, the reaction is you get a water uh, molecules and you get a salt that is made, and so that's why it has that really just bitter nasty taste to it. And so that's probably why we will not see things like these products come about: a hot pocket, bag of chips, and some ice cream. So today we're gonna write out those reactions, and we'll start neutralizing reactions, and we'll see that there's always going to be a water molecule and some type of a salt that is made. So
Okay, in these neutralization reactions, just remember we got acid reacting with a base. We're always going to get water and a salt of some kind. Neutralization just means that they're kind of neutralizing one another, almost canceling each other out. And if you remember, acids are corrosive and so are bases. And so this is kind of interesting to see when they react, we actually get water molecules from that. So your homework is going to look something like this. It's just the words, and you guys have to use the information that we've done already to write and balance these reactions. So they're going to be a double displacement reaction. So nitric is 8, ic is 8. So if you remember, this is going to be HNO3. Okay, hydrogen's a +1, nitrate's a -1. So I don't need to put any little numbers. Cesium hydroxide is going to be CsOH. All right. Cesium is a plus, and hydroxide's a -1. So this is going to be easy. We're going to write water. I'm going to write it differently for you so that you guys can keep track of those hydrogen and hydroxide. So we are totally okay with you writing water like this because the hydrogen is now going to bond with this hydroxide. Okay, positive, negative, and that's how it's written. So it's okay to leave it like this. We know that that is a water molecule, H2O. So you don't need to fix that for now. Okay. So then we're going to get cesium nitrate. CsNO3. So I'm going to still check. Right? So these are all plus and -1, so I don't need to put any subscripts, any little numbers here. Okay? And if this really bothers you after you get done balancing them, you can write this as H2O if you need to. Okay? So they're pretty straightforward like this. Let's do one more. Okay? What would hydrosulfuric acid be? Hydrosulfuric. See if you guys know. All right, it is going to be HS. Okay, hydroic means that it is off the periodic table. So just hydrogen and a sulfur. So hydrogen's a plus, sulfur is a -2 off the chart, so I need a little 2 there. Lithium hydroxide. Lithium, Li, hydroxide. It's a plus and a minus. Okay, we know that this is going to react and we're going to get a water molecule and lithium sulfide. So double displacement. So I'm going to have LiS. Lithium's a +1. Sulfur's a -2. So this has to come down here. So that's 2. Now, we still need to balance it. Okay. So I have 2 hydrogens here. Yeah, I have 2 here, but this is our hydroxide, right? And so I have 2 hydrogens, so I need to put a 2 in front to make that 2 hydrogens, okay? I have 2 lithiums on this side, so I need to put a 2 in front, which is what I needed to do anyway to make the 2 hydroxides from this side balance. So this is why I think it's easier to keep water written as HOH, okay? And so you can keep track of them on both sides a lot easier. So that's the way to attack these neutralization reactions.